All right, let's get this started. I prefer to start right here just so people know how I got here. You know what I mean? All right. The good and the bad of C++ as a Rust developer. I just assume that all Rust developers just think they're all bad. Am I wrong on that one? I thought all C++ was bad. If it's not Rust, it's bad, right? Or am I wrong here? Oh my gosh, there are professional Rust programmers now. Oh my gosh, everybody get your programmer socks on. There are professional Rust programmers out. I'm a professional Rust programmer, and I admit I'm a bit of an evangelist. So you can imagine my pain when my little sister, with the very little programming experience, said she wanted me to teach her C++. Based little sister coming in, wants to become a game programmer, doesn't want to use Rust. Awesome. I tried to explain that one day she'll be debugging seg faults with Valgrind and looking back at this conversation as the place where it all went wrong. But she proved to be even more stubborn than me and insisting on learning a programming language people actually use. Haskell devs in absolute shambles right now. Oh my gosh. If Rust isn't actually used, then Haskell devs, there is no hope for them right now. That is painful. Great start though. I hadn't written any C++ since making games with Cocos 2D X in high school, but I decided that my vague memory of the rule of 3, or was it 5 or 0? I think it's grown over time. And other such matters would be more than sufficient for the task. It turned out that I had some learning to do, but I was pleased to find out that there is a large opportunity for knowledge transfer. Nearly every C++ concept can be easily understood as, oh, it's like this thing in Rust. Yeah. And you can do the inverse too. And while C++ has its warts, it's a beautiful language in its own way. I already knew this, but in relearning C++, it became even more clear that to whatever extent Rust surpasses C++, if you believe that it does, it's only because Rust was able to stand on C++'s shoulders. C++ did walk so that Rust could run. It is a fact. We would not have got to where we got to without much foot shooting and much pain. And so I'm glad, the recognition feels good. I'm happy about that, okay? It makes me feel happy when people realize that things aren't black and white. So we spent a couple weeks following the OpenGL tutorial series from a YouTuber named The Cherno. The series is excellent, by the way. And after 2 weeks, we managed to get a single inert blue square on our screen. After 2 weeks. Let's go, game programming, let's go. Cherno is an epic C++ teacher. Done. Blue screen. Dude, Tone did this in almost no time. Blue square. Gone, done. I was beginning to be afraid that my sister would question whether this was really the best way to learn a game and make C++. So at that point, I decided we should peel off from Mr. The Cherno's tutorial and study making the game in earnest. While we started implementing gameplay features and factoring them out into rudimentary game engine, I am proud to say that we now have an actual game you can download and play. Codename Space Boom. Oh, that's kind of funny. Is there like a little web page for it? Is it really nice? Oh, nice. Look at that. Little CMake Jinja. Okay, nice. We might have to give that a little bit of a shot at the end of this. Once things were generally split into the engine side and the gameplay logic side, she ended up taking the wheel on gameplay, implementing much of it completely on her own. While I responded to her feature request on the game engine side, feature. Nope, sorry. As the product manager, I'm going to say no to the game engine dev. I know that's game engine dev life right there, boss sister. Yeah, I'm loving this. Great. Good on the sister for this. The good of C++. C++ is a very freeing language. I think anyone that does Rust for a while and then stops doing Rust for a moment, I think you gain both a new appreciation for Rust, which I have, and you also realize its restrictions, and it makes you feel better again. It lets you write code now and fix it later. Is what you're trying to do a bad idea? That's up to you, not some nagging borrow checker or pompous language designers who think they know better than you. Go ahead and dereference that pointer. What's the worst that could happen? It crashes or does something weird? It's a video game, man, and besides, you already made the decision to write C++, so clearly something being a bad idea hasn't stopped you before. Yes! I love this. But it is true. When you're used to using something like Rust and you use a non-Rust language like Zig, it does feel good. Like, it feels great. All of a sudden, you're just like, oh, yeah, hell yeah. I can just do the thing, right? A Rust Defender right there. Yeah, no, which is great because he took Rust and shot it, and then C++ was like, ha, and then he shot C++ too, which is great. I'm joking a bit there, but C++ seriously lets you do whatever you want. I ended up writing this horrible template for memoizing types that can be shared but have Ray. Oh, no. I hate templates. Templates are absolutely disgusting. I hate templating. I don't want anything to do with it. I hate, somehow, every time I've ever done anything with template stuff, it always becomes just awful. Here, let me show you my template meta framework. Yo, bro, I heard you want to see a template meta framework. Which let me quadruple our game's FPS with only very minimal changes to the gameplay code my sister was writing. Oh, that's cool. We don't stress about passing floats to functions that expect integers, although eventually the compiler warnings build up and we get around to fixing them. I love it. I love it. And if we need a global variable, we just make it static and ask questions later. Also, great. I'm good enough at Rust that I've internalized the Rust ways of doing things and can sketch things quickly despite all that. But I don't feel envious of the alternate timeline versions of myself where I'm enlightening her about one cell and arc ref cell. I love this. This is so funny. This is so good. Absolutely beautiful. Expressiveness. Object-oriented design is also super nice. Really? Get that out of my mouth. I know everybody hates on object orientation. But it's extremely pleasant for writing games with. We make a game object class, then game object that are squares constrained to a tile grid, get a square object subclass, and then square objects that move around get a character subclass, and so on. Oh gosh. Then all of these go in one giant vector unique game object, and you call update and render on each one of them, and it calls the right thing and just works. Arc huck 2 on that one. I mean, okay, fair. By the way, fair on that, because I guess you could argue that you could do this with a trait, right? You could do this with a trait that has a render. OOP is not for games. I mean, I built a game and I didn't use OOP. Not planning on using OOP, but I know a lot of people use OOP for games. Okay, type 1 in the chat if you are a game designer, or you work on games, you program games, you work in some aspect of gaming. Hobby only, that still counts. Okay, so a lot of ones. Type 69 in the chat if you use object-oriented, and type 420 if you do not. 420 for I do not use object-oriented, 69 if I do. Pretty telling right now. I know it's pretty prolific. 69 and 420 sometimes. Wait, do mind games count? They do. So I know it's pretty prolific, even though I don't really like the idea personally of object-oriented if I can. Bro, ain't no way there's that many game devs in here. I mean, there's 1,900 people currently. I would expect a decent amount of game devs. Why not? 100 game devs, 200 game devs, why not? What you forget is that so much... I think the problem is that there's this thing that happens in the programming world, and I would personally blame Twitter for a good portion of this problem, which is that somehow we have this idea that there is the web world, and then there is like embedded, and then there is like games, and then there is I'm not even sure ML, right? And what's really big is this right here. Web is huge. Then there's like maybe a little bit on compilers and a little bit on networks, and there's a little bit on operating systems, and there's a little bit on like performance, right? These are all just like little things. Ballsack coming in. Ballsack coming. We're not doing it. But the web is still like the predominant item. Everything else is just a small amount. A little bit of databases, a little bit of DevOps, right? And the rest is just all web. But that's not actually true. This is not an accurate view of the world, though I think that a lot of people have this view on the world. A little bit of Monica, a little bit of Rita. I think he messed up. He drew a lot of toes. Yeah, a little Mambo number 5. The web only seems predominant because that's where you read the stuff. Yeah, I would like real stats. Honestly, I would like real stats too. I think it was Theo who suggested that over 50% of all repos on GitHub are web-based repos. I never said anything that clones are trash. Clones are just a way for you to get around problems in Rust. 50%, really? But I mean, again, I think that's because your view of the world is this. 20%. The clones are trash. Have you seen their aim? If they had been decent shot, the Sith would have won a long time ago. It's true. It's very true. The clones do have terrible aim, and the Sith should have won. You know what I think they should do? Star Wars idea. Since we're on this, since we've completely derailed from the C++ argument, I think there should be a world that exists in which Star Wars makes a movie kind of like Rogue One, but call it Programmer One, who actually secret agents into the dark side and creates the software poorly that makes the AI not shoot good. Prog 1. It's the only possible explanation for why why they were able to make robots that could scale the real world terrain but not be able to shoot accurately. Do not believe it. This is a great plot. You're a natural entertainer. Thank you, TJ. Thank you, TJ. I feel like I could play this. By the way, Disney, if you would like to hire me, Prog 1, I could do it. Just saying. Bro is on to nothing. Shut up. I historically was a big user of the Rust game engine Bevy, see automated testing in Bevy. And there's a lot to like about Bevy, but Bevy is supposed to be the gold standard of easy-to-use ECS, and making a game the way we did in C++ is just way more fun and productive. It's kind of shame that using a real game engine ends up being worse developer experience than some C++ my sister and I cooked up in a few weeks. Sometimes that just be the case. I think this is a better argument for why sometimes writing a bespoke thing for a bespoke problem is better than writing one really large or using a predefined path that works for 99% of games. All right, Teach, what'd you say? It'd be great if you got hired to do that role for Disney because you'd only have to do one season. That's funny. I heard Acolyte was horrible. I have seen so few people that say Acolyte was great. Anyways, there we go. Now I got a whole bunch of people in the YouTube comment section. Actually, Acolyte was really good. Actually, you just don't understand why it was really good, and you're just stupid. All right, it's not a fair comparison since Bevy sacrifices some developer productivity for a lot of performance and is rapidly improving. But still, it's the C++'s credit that we are able to quickly get something with a great developer experience working. Debugging. I really love the debugging story in Visual Studio or VS Code. I don't know why, but it feels this just doesn't even exist at this level for Rust. I mean, C++ has been around forever. One would assume that Visual Studio has a debugging experience in C++ that is absolutely amazing. Even if it's possible, it's for some reason never been what I reached to. I always run my first Rust projects with Cargo or Bazel, and this loses something compared to being able to press a button in your IDE and just click to add breakpoints and whatnot. In my Rust career, I've used a debugger maybe once. Everything else has been printf debugging. I do a lot of printf debugging. I should probably do more more regular debugging. I actually do want to set up the debugger in NeoVim. I do. I think this might be a print L debugging. You can print F your mother. Modern C++. There's a lot of old features you should generally not use over modern C++ equivalents unless you have a specific reason to. Chars, stars, arrays, pointers, malloc free, null, etc. It's like in a way it's like the classic image. Yep, classic image. The upside is that modern C++ is actually very nice, especially unique pointer, shared pointer, standard array. Absolutely. The result of using these is that you mostly don't worry about memory safety. Absolutely. Of course, we did run into a few seg faults anyways in the course of developing the game, but they're always easy to fix. Unique pointer is generally a great thing. Generally. I do attribute some of the success to my Rust experience, though. Well, yeah, you have to know why you want to use this, and use this even when you don't feel like it's useful. Unique and shared pointer are fantastic. We have a vector of game objects that we wanted references to them to be valid across frames, so we wrapped them all in unique pointer, allowing us to append to the vector without risk of invalidating the references. The fact that references are invalidated when you append to a vector is obvious if you know how vectors are implemented, but I could easily see a newbie to this type of programming running into that issue. I assume what he means by that is the following. You have vector, and it has A, B, and C in it. And you do something like ampersand V0. You get the reference to this bad boy right here. But then you push on D, and the vector goes from this place in the heap to this place in the heap over here because it runs out of space, and it must reallocate itself. And therefore, your reference to A, or to 0, just explodiates, or some other mutation type stuff. Correct? As a game engineer, this is one of the most common crashes I have seen associated with engineers cause. Oh, nice. Correct. Right? Is that what? Because you can't really do this in Rust. Like, this is just not like you can't do this thing, right? These two things you just can't do. Oh, damn, I'll admit I know how arrays work and I didn't put two and two together. Well, I mean, vectors are dynamically allocated, right? I know you're saying array, but vectors or these type of dynamic array lists, right? You drew a dick again, did I? I didn't even get close to a dick. Okay, mildly close to a dick. I got mildly close. All right, the bad of C++. Let's hear about this because honestly, all those things he said were great, but I know for a fact you're not actually considering all the potential bad parts. C++ has the unfortunate but also awesome position of being an hierarchy of changes on a language originally developed in 1973. Very rarely breaking backwards compatibility. This is a huge technical feat, and I don't think it's fair to hold it against it. It often makes things a bit confusing, but it's preferable to the alternative. However, I do think there are some unforced errors in C++ that maybe could still be corrected without causing mass chaos. Building is not easy. Absolutely. The lack of standardized build system is really frustrating. She uses Windows. I'm on my MacBook. At some point, we switched from using straight-up Visual Studio to CMake. CMake is a great piece of engineering, and maybe I just don't know how to use it. Admitting to skill issues is the first step to skill issues. Also, I've been in CMake. I've been in some pretty serious CMake world, and it can be very ugly. But the user experience of using it with Visual Studio is not great compared to Cargo. Visual Studio has a CMake mode that works okay, but it's clearly second class compared to using real Visual Studio build system. And we ran into a ton of bugs that forced us to close and reopen it regularly. And in one case, couldn't be resolved without a restart. Cactus, check that out, Cactus. I forgot to turn off alerts. Cactus, thank you, Cactus, but look at that. Obviously, Microsoft products being buggy isn't exactly C++'s fault, and I can live with CMake, but it would be nice if CMake at least made things easy and tried to avoid works on my machine issues. On the upside, CMake has a great VS Code extension that is quite user-friendly in my limited experience. I never liked the problem is I have this really ignorant point of CMake in the sense that I think a lot of people have the same ignorant view of CMake, which is you use it, but you use it kind of like a machete in the jungle. You're like going through and you're just trying to slice directly to where you want to go. You get what you want and you get the hell out of it, and that's that. And so my view of CMake is really limited. I never actually properly went through the experience of learning CMake all the way. I did do a little bit of learning, but nonetheless, it's just like so little that I think it's horrible, and maybe it's just because I suffer from skill issues. I don't think that is ignorant. CMake is hot garbage. You're not. It's just junk. I know. I mean, I've heard very, very few good things, but I can also admit that maybe I've been a little bit ignorant in my perception of CMake. I do think it's important to be willing to understand that your perception of CMake is not the best when you have very little experience. In fact, CMake could be much worse than I'm making it, just due to the fact that I don't know it. But it could also be much better than I'm making it, right? It could be one of those things where I'm neither right nor wrong in either direction because I don't even know which direction's up. It's the old working smart versus working hard. I don't even know how to work smart. Therefore, I just need to work hard on it. All right, let's see. Package management is not easy. Ooh, this is kind of exciting. Some people have told me about Conan and VC package, which seems CMake package manager. Stupid. Some people have told me about Conan and VC package, which seems like they solve a lot of problems mentioned in this section. However, I've left it in for posterity. The lack of package manager in CMake is also a huge time waster. Okay, fair. Ginger Bill has such a unique take on this, which is package management is bad. I'm kind of like, I'm not sure where I stand on these things. Is it better to vendor in your libraries and be more conscious of the dependencies you take and really be conscious of when you want to upgrade? Or is it better to have these systems that allow for really easy linking of everything? Which is just, I see both of the problems. I love the ease, but at the same time, I really dislike not just being able to be like, give me that HTTP server. Just give it to me, right? I mean, Rust also has a really poor standard library. It doesn't have all the things, like, Go, you can pretty much do everything in the standard library, whereas Rust has very little, so you find that you do JSON serialization by downloading something. You do args by downloading something. You do HTTP by downloading something. You do everything by downloading something. Ginger Bill take only works in Greenfield like Odin. With C++, there's no way you can vendor everything. You just don't have, or you just don't have depths. I mean, it's hard to call Ginger Bill's stuff, Greenfield. I mean, it is 10 years old, and he has a very large and successful project that's millions of lines of code in Odin. So, I mean, it is possible. I'm just not sure. I don't know. We didn't have package management on a multi-million line code base in C++. So I just don't know. It has been a huge source of works on my machine type issues. It seems like C++ developers like to install packages globally and then have their build system somehow find them and link them. But what will happen is that I'll try to do something on my Mac where apparently I already have the library. Then my sister will try it and she won't, and it won't build. And I've been working around this by just building everything from source as much as possible. The workflow is for building library dependencies from source seems to be that you add the repository as a Git submodule, set up add subdirectory, and include directories. Ooh, I know those CMakes in CMake. Then add the library in target link libraries. It's not always easy as it sounds, though, since some projects like Glue aren't designed to be used as Git submodules, so you can't actually dump a ton of their code directly into your repo. And knowing what library to use target link libraries wasn't obvious for me for some reason. I wasted a ton of time with Glue before I realized that I had a link with Glues and not Glue. See, I know all these words and I've used them in CMake. I just can't even remember the problems of them, and that's that. Not to mention that most libraries we use seem to have a CMake folder with a README that basically says, hey, some rando added this via a pull request, and I don't really know if it works, but you can try it if you want. Hell yeah, brother. Hell yeah, brother. And if your dependencies, yes, submodules can have submodules. By the way, I'm not opposed to Git submodules for this case. I think Git submodules in this case is actually not a bad idea. The reason why is that it's a point in time in which something does not change. Everybody gets the same version. The only time that submodules suck is when you're changing submodules all the time. Submodules changing it all the time says that there's something probably not submodule-y about it. But I generally don't have the same problem that a lot of people have when it comes to submodules. Git submodules are a pain to set up, though. Are they? Are they? You can add it with a suppository URL. You can add it with the path. You can update, init, and recurse. I mean, I don't think they're hard to set up. I think that most people just use them wrong. I know a lot of people say they're pain and they're bad, but I don't think they're all that bad. A suppository URL? Yeah, it's a good joke. It's a good joke. They're a pain when you combine multiple projects. They're a pain when they change. If you're constantly having changing on your submodules, I think that it is really annoying. I think that is really, really annoying. Git submodules are a mistake. I don't know. I think they're really good in a vendored world. Oh, well, I did not expect this high from Mr. Primogen. Well, hello, Chad. I recognize that name. Look at that name. Look at that name. Look at that name. That was my StarCraft in me. Effectively, everything you're saying, I pretty much agree with. This has been a fantastic article, by the way. Absolutely beautiful. We're arguing the merits of submodules. Chad incoming. Yeah. Subtrees don't count. Subtrees don't count. I never used them, but there's always tears for when somebody talks about their firsthand experience with them. I've had very few good experiences with submodules. We had a submodule that was the protobuf definitions of the game objects within Netflix's real-time gaming logs. And so that, for me, was very nice because I used that submodule definition, and whenever I needed to update it or anything, I would update it. If I needed to make changes to it, I'd make changes and commit it back. It was just like this nice little point. I generally enjoyed it. All right? Is Code Girl on YouTube? Suck it, Code Girl. She's on Twitter, and I think I've seen her over here on YouTube. Oh, this is top chat. We got to go to live chat. There we go. Hey. You want to see some real closure? You want to see a real programmer? This is where you go. Okay. Error messages. The error messages of C++, both with Clang and Visual Studio, are really rough compared to Rust. Rust is pretty rough too, though. I mean, to be completely fair, once you reach a certain level of rusting, the errors can be a bit rough. Like, I'm not talking about the basic errors. Basic errors, Rust is out of this world. Absolutely fantastic. You forget a parenthesis, and it's not going to give you some crazy error. It's going to give you a very hey, you probably forgot it right there. Oh my gosh, it's a spider! Right? Oh man, that spider was on me, and it's a big one. Oh, you're so fast. Die, Satan! Got it. I gotta figure out where all these spiders are coming from. That is the third one today I've killed, and they're all like this big. And that's just like uncomfortably sized spiders. I don't know what it is, but that is entirely too many spiders, and I've somehow accidentally created a spider farm. So you're saying that's big? Yeah, that's about 6 inches of spiders. They're inside the computer. It's getting cold out. Getting uncomfortable. Spiders found in the balls right next to the microplastic. It's like actually spider season. I know, they're everywhere, and they keep crawling on me. I don't want spiders crawling on me. Yesterday, I had one come down right in front of me, but it got away from me. Async Rust tutorial when? I'm not doing Rust tutorials. I don't like doing tutorials because tutorials are transactional. They are. Generally speaking, I don't do tutorial stuff. I'd rather make like a bigger course that goes into something, right? I'd like to do a project. Projects are fun. Anyways, but Rust does have better default error stuff. It's significant, just wildly better. But I think once you get into the async trait world, then things can get kind of ugly. I'd guess that the error messages are my sister's biggest impediment to learning C++ outside the build system situation. By the way, templates make crazy errors. Some of the errors I had at Netflix while I was building, I swear they were thousands of lines long, and it was terrifying. This is what happens when I change the function signature in the header, but not in the CPP file, or vice versa. Oh yeah, linking errors. When you hit linking error stage problems, yeah, I don't even know what I'm looking at. Concepts fix these, do they? I've never played with concepts. That was very short. I know. Hey, Chad. They do not. Hey, Chad. These are some rookie number error lines, Chad. I need you to pick this up, Chad. Okay. Rookie number errors. I want to see errors that are 10 times longer. I said, dude, some of those template errors are just. I just have. Whenever template errors or linking stage errors can be some of the hardest ones to figure out, and I find linking errors to be really, really emotionally painful. They're like terrifying. I know, but people are saying this is a very nice one, but like, look at how much. Generally speaking, look at how much crap is here, okay? Look at all the crap that's here just to make this error come out. Yeah. I know this error is really simple, but if you did the same thing, if you could create a similar-esque error in Rust, it would be like, yo, this function here is trying to reference something that does not exist over here. And it has great LSP integration, okay? Here, I'll give you an example. It's been so long since I've done anything in Rust, it makes me feel weird. Is it printf? I can't remember. And then I have to go here and go use other. Dude, it's been so long. Is it create other? It's been so long. Oh, it's print line. Dude, it's been so long since I've done anything in Rust. Holy cow. What's the way to get these things in here? I have actually forgot how to do this here. Why aren't you bringing it in? Why isn't it bring? Oh, is it? Oh, you're right. It's mod other. Okay, yeah. You're right. And then it's. Then I go other.foo, right? Well, look at it. Let's see on. Look at this. Look how nice that is. It's like telling you right now what's going on. Sorry, it's been like 8 months since I've touched Rust, so I have to remember all the little things. You know, there's every single language has its own little fun oopsie daisies that you have to know. But like, look how great that is. I know this is not fair comparison, but generally speaking, Rust on the simple errors are really, really nice, right? Hey, you're using it here. You define it this way. You goofed up. Generally speaking, it's really good. And it's even pretty good with trait stuff, meaning that if you have a trait, say a read trait or a write trait that you need to be able to import in, but you're using a socket and you don't remember, it'll say, hey, you're using this function, and this function only exists only if you import this trait. You probably mean to import this trait. Like, it's pretty dang good. That's not the equivalent of a linker error. Yeah, I know. I don't know how to create an equivalent of a linker error in Rust, okay? I don't know how to do that. Anyways, generally speaking, Rust error stuff is very, very beautiful. Let's go like this. Let's see. Oh, once you know what all the terms means, it's precise and straightforward. But imagine someone like my sister who barely knows the difference between declaration and definition. It doesn't even directly say that the definition is in render CPP and the declaration is in renderer H. I know that having good error messages in all cases is probably not achievable given C++'s design, but this particular case and other simple ones seem pretty easy to improve. I do think it's easier to improve. I mean, improving error messages should be 100% one of the goals of any language. A module is a thing in C++ 23. Yeah. Are modules actually implemented? I think everybody should agree that good error messages should be one of the top priorities of a language. And I think that's one of the reasons why Rust has gotten as popular as it is because it is such a very, very well, like all the simple errors, all the things that get you up and running, all of their errors are really nice. Why have error messages? I write Rust so nothing ever errors. Yes, concepts. You're talking about concepts, right? Template constraints are concepts. I only read about I have do I have it on there? I know it's somewhere in here. I have effective modern C++ and a tour of C++, and a tour of C++ is written by Bjarne, and that was really nice. Like, it showed me concepts and all that. But I have never used them in practice, so I'm not very good at them. Right? I've only just read for them. Yeah, but I mean, you can say the same thing for Rust and their trait stuff. Sometimes those trait stuff in Rust just gets so emotional, right? When you're sitting there and you just have something that's, you have the where T, I forget the even syntax, where T equals, I forget what it is, send plus static plus, wait, what is it? It's static plus sync, right? You have all these things, and all of a sudden they just become these huge walls of these generics, and you're just like looking at them. They can become pretty ugly. And then you start having them flow through all of your structs, and then all of your structs have them, and then some of your struct methods have them. And I know there's a better way to handle it, but I don't know how. We're T-sized. A lot of T-sized. A Fluge? Thank you, Fluge. Yeah. Plain traits, awesome. Trait bounds? Yeah, trait bounds can get really, they can get really tricky. Yeah. Bevy can produce horrible error messages. But that's because the errors they're producing are really complicated. And I think so, and if you use Go or you use JavaScript and you go to these languages, it's very hard to understand why these messages are so dang hard. And so I think a lot of times we dunk on these error messages, but I think the problem space itself is really interesting. Anyways, yeah, framework error messages are generally really hard. Even TypeScript. Like, have you seen some TypeScript generic error messages that are just like these really, really long rows of stuff? Like, you can get terrible error messages even in TypeScript because it's effectively just like one dynamic ethereal template object. That's very confusing. I was an OCaml dev before I started writing Rust. You low-key miss it, dude. Chad, you should know Tej. Tej is a OCaml boy, dude. He's gonna come in here and he's gonna just start talking about You said it. You said OCaml, and oh man, he even went to Jane Street and gave a talk about NeoVim and OCaml. I'm literally writing OCaml right now. He loves OCaml. All right, anyways, this is a great article. I loved everything about it. Git submodules also seem like they barely work to me. Why are they not updated when I run git pull? That's a great question. This is such a bizarre thing. Submodules are cool, but it feels like they were designed for a different use case. Yeah, I mean, they feel like they're supposed to be for vendor libraries, but then there's also all these weird oddities. I just feel like submodules have always been half-baked because nobody knows how to handle versioned vendored libraries within your application, and it's just a very difficult thing, and typically we just hand that to a package manager, which is able to do that. Yeah, the previous article was so bad that it made us sad, so the new one is really great. Why is async hard in these low-level languages? Because async is a concept from a high-level language because it gets to stand on the shoulders of interpreters. It's very hard to do these things in low-level languages. That's why. Nice. Like Go doesn't have async await because it just makes things very hard. Async is very nuanced and works differently in every language. Yes, some are pull, some are push models. Like with JavaScript, when you say new promise, the constructor executes synchronously, which means it's a hot promise. Whereas in Rust, when you do some async function, you call it, it's a cold function, right? It's a cold promise. You then have to call await on it for it to actually start executing. That's because there's a big difference between the two. Technically, in Go, every function is implicitly async. I don't think so. I don't know if that's true or not. That doesn't feel true. Hot promises. My new romance novel. Bro, you want some hot promises? The name is the Primogen.